the competitiveness cluster, who is partner of the NewSkin project. The NewSkin project is going to be our topic today, and we are going to present you the open calls of NewSkin, which are great opportunities for SMEs and research organizations to participate in the project and to develop nanotechnologies, advanced surface nanotechnologies. So we are going to have a look at the agenda, but before to go through the presentation of all the speakers, I have some technical advice for you during this webinar. You have the opportunity to ask questions with the chat tool. So during the presentations, you can write your questions in the chat, and at the end of each presentation, we will have some time for questions, and I will read your questions, and the speaker will have the opportunity to answer you. So at the very beginning, I'm going to do a short introduction of the NewSkin project that you might know or not, and then my partner Elvin Fetai from Confindustria, based in Italy, is going to do an introduction and a presentation of the NewSkin open calls, and he will explain you how you can join the project and how you can benefit from free services. And then we will have 3 presentations introducing some of the NewSkin technologies. First of all, Girolamo Mincuzzi from Alphanov is going to do a presentation on the laser technologies available within NewSkin for surface texturations. Then Pablo Benguria from Tecnalia is going to introduce the testing facilities that are available for anti-fouling, anti-corrosions, and tribological coatings. And the last presentation on the technological offer of the NewSkin project will be done by Thomas Kubart from the Uppsala University, and his presentations will cover the high PIMS technology, which is an innovative PVD coatings. So you will know more about the technology development and also the offer through these 3 presentations. And then at the end, I will do a short conclusions, during which I will give you a few words on the NewSkin ecosystem and on the NewSkin platform to help you to participate in the project. So I might start now introducing the NewSkin project. NewSkin is a Horizon 2020 project, so it's financed by the European Commission. It is composed of 35 partners and has a grant of 15 million euros. The aim of NewSkin is to accelerate the industrialization of new advanced surface nanotechnologies. We have 3 types of organizations that are partner of the NewSkin project. On the left side here, you can see 14 research and technology organizations, among which we can find Alphanov, Tecnalia, and the University of Uppsala. And we have also other important RTO at the European scale, such as Fraunhofer, Leica, Tita Innova, and many other RTO. The role of RTO in the NewSkin project is to develop surface nanotechnologies in order to transfer them with our ecosystem. During the first 2 years of the project, this RTO have worked with SMEs that are partner of the NewSkin project that you can find at the bottom of this slide. And these SMEs had the opportunity to validate the technologies. Then on the right side, you can see 7 organizations that are cluster and associations of enterprises and research organizations. So we can see here ALPHA-RLH, for instance, and also Confindustria. The role of clusters within this project is to transfer this technology within our members. So that's why, for instance, we're organizing this webinar to give you the opportunity to know about the technologies that were developed within NewSkin, and also to let you know how to participate in the NewSkin project through the open calls and other services, so that you can also upscale and integrate the NewSkin technologies. So the NewSkin Technologies has quite important range of is concerning a quite important range of economic sectors. So on this screen, you see the different type of economic sectors that the NewSkin will address, such as structural steel, automotive, aerospace, and industrial components, marine transport, machining tools, water treatment, films, lenses and packaging, orthopedic prosthesis, constructions, and renewable energies. For all these sectors, we are expecting to have specific effects available thanks to the NewSkin Technologies, such as corrosion resistance, reduction of friction, anti-fouling, surfaces resistance. We can have as well enhanced wear resistance for machining tool, anti-reflective coatings, antimicrobial coatings as well, biocompatible surfaces for the health sectors, and we have as well many other effects that will be able to develop with coatings, laser texturations, and physical vapor depositions technologies. So the NewSkin project will offer its technological solutions to different type of organizations. It will be the case, for instance, for technology developers such as other research centers who are willing to scale up surface texturation technology that is available within NewSkin. So we'll be able to you will be able to integrate this technology within your facilities through the open calls and through the services of the NewSkin project. Also, end users, so SMEs or large enterprises who are willing to find solutions for a specific problem linked with surface texturations, will be able to connect with the NewSkin project to obtain services for a prototype, for instance, and discover surface texturation that is answering one of the needs of your company. We will also be able to offer companies the opportunity to collaborate with the NewSkin project to develop new surface treatment technologies. So if your company has the capacity to bring technologies that can be integrated within the NewSkin project to improve a machine that can texture surfaces, we can also collaborate within this project. And also, NewSkin is aiming at gathering an ecosystem of stakeholders, so companies, researchers, clusters who are interested in advanced surface treatments. And we have developed a platform that you can join, and on which you can as well connect with the NewSkin partners, but also with the whole ecosystem of the NewSkin project. On this picture, you can see the range of services that will be available thanks to the open call that Elvin will present during the next presentation. So we have a wide range of services from the design of solutions to the commercializations of nano-enabled consumer products. Between these two services, you will be able to ask for developing a specific prototype that will be textured with the NewSkin facilities. We can also do performance evaluations and benefits qualifications such as LCA approach. We can also evaluate the economic impact of your projects and other impacts such as social, environmental, and regulatory. So as you can see, the NewSkin project has a wide range of services, and now we are going to launch the first presentation of this webinar, and Elvin is going to introduce you how you can participate with the NewSkin projects through the open call. Thank you. So Elvin, the floor is yours.
Good morning to everyone. Thank you, Romain. Thank you for having me here. I am Elvin Fetai, Research and Innovation Area Officer at Confindustria Emilia. And as Confindustria Emilia is in charge of the work package dedicated to the open calls, I'm going to present you the opportunities and the procedures to apply for the services of the NewSkin project. I would start saying that in the upcoming 2 years, until 2024, 4 different open calls are forecasted, one every 6 months. The first one has already been launched, and a deadline has been set already for the last day of December 2021. The second one will be in exactly 6 months after, and the deadline will be at the end of June 2022. Then again, for the third one, the deadline will be at the end of December 2022. And for the last one, the fourth, the deadline will be the 13th June of 2023. For each of these open calls, there will be 25 awarded entities with free services provision. In total, we plan to produce 100 case studies, and so 100 entities at the end of the project will be supported through the NewSkin services by the expertise of the partners and their, of course, upscaling and testing facilities. We also specified that there is not a limit for the services we can offer. In these terms, for each call and for each proposal, the value will be evaluated by the partners, also depending on which, for example, is the amount of services requested, and, for example, the component that have to be treated in terms of dimension or type of surface. As you can see here, the 4 open calls will be consequent. So this means that in time, the application windows and the effective execution of each open call will overlap in these 2 years. As I said before, the first open call has already been launched at the beginning of October, and the deadline is on the 31st of December 2021, and you need to apply for your proposal to be considered eligible before 5 p.m. The actual execution of the open call will be carried on in the period between the beginning of April 2022 and the end of September 2022. This means 3 months after the deadline. As regard the evaluation, we can say that it will start immediately after the deadline. There will be a first preliminary check conducted by us, through which we will be able to ascertain the eligibility of the received proposals. These proposals will be then transmitted to an evaluation committee, a group of experts composed by 8 experts with both market and technical knowledge. This evaluation process will last 45 days, at the end of which the results will be published. And after the publication of the results, discussions of the agreements with the awarded entities will start, and contracts eventually will be signed at the end of other 45 days. Then the free open access to the services will start, and it will be done in the next 6 months. But who is able to participate to the open call? Who are the eligible entities? We specify that all kinds of companies can participate, namely startups, small, medium-sized enterprises, but also large enterprises. Also, research organizations are allowed to participate, so research and development organization in general, but also higher education establishments. Another important thing to say is that there are no geographical restrictions. This means that even entities coming based outside Europe are able and allowed to participate to the open call. Now, how is structured the application form? The form is you can fill the form in all its parts online. It is a quite easy application form. It is structured in 4 main sections. The first part is dedicated to the applicant and company information. The second part, we ask you to present to describe your company, especially in terms of R&D efforts, main objectives, and sectors in which it operates. The third part, the part C, description of the case study, I would say is the most important one. This part is divided in 3 subsections. The first one dedicated to the excellence in terms of the challenge that need to be addressed. So we ask you a description of the problem that need to be solved. The second one called implementation, in which you describe why the service you chose from the NewSkin catalog can technically solve your problem. And a third one, in which we expect you to describe which could be the expected results and the potential impacts. In all of these subsections, you will be able to attach supportive images or documents that you think could support what you declared in the application. There is also a limit of words. There's a maximum of 1,000 words for each subsection. And after this, the last part, the part D, it only consists in authorizations that you need to give and to flag. So which will be the criteria that will be considered by the evaluation committee in evaluating your proposal? They correspond to the subsection of the third part, namely excellence, impact, and implementation. Excellence, considering this criteria, the relevance of the problem that need to be addressed will be considered. Through the impact criterion, we will consider those that could be the expected results and the potential impacts. And in terms of implementation, the proposal will be evaluated in terms of adequacy of the service you requested and its actual efficiency in addressing the challenge you proposed. Now, as I said before, there will be an evaluation committee that after the first preliminary check will evaluate your proposal. This evaluation will be done through awarding each criterion on a scale from 0 to 5. There are 2 main conditions that need to be respected for your application to be considered eligible. An overall threshold of 10 out of 15 and a threshold of each individual criterion of 3 out of 5. How can you apply? The first thing you need to do is to register on the NewSkin platform. In fact, only registered users will be able to proceed through the application form. After you registered, you need to go to the open call sections, and from there you will find the link that will allow you to open another page through which you will complete entirely online and fill your application. In this page, you will also find some useful links you could need through your application filling. And you will find some contact to some email addresses that you can use if you experience any kind of issue, both technical or conceptual. There is also the possibility to save your work in progress during the filling of your application form, and you will be able to start whenever you want to complete, starting from the point you left without losing your work. For more details regarding the entire application process, the evaluation process, I suggest you to check the links you will find in this presentation that I think will be shared with you, through which you have the chance to see the guide for applicants, and also the catalog of services, a presentation in which we explain which are the main value proposition of the NewSkin project available for this first open call. These documents are also available, as I anticipated before. In the page will be redirected to apply for the open call. And of course, we encourage you to contact us. By clicking on Contact Us, which is here highlighted, you will be automatically redirected to our email address of the open calls, and we can help you in each moment of the application. So if you have any question, feel free to ask, and I will be glad to answer.
Thank you, Elvin. I don't see any questions in the chat at this moment, but we have some minutes for you to ask some question if you wish. And during this time, I have one question myself. Is it possible for one company to submit several proposals during the 4 open calls?
Yes, thank you. Thank you for the question. Yes, of course, there is no limit in terms of proposals or services a single company could ask for. So feel free to fill more proposals if you want to, and we will evaluate as they are proposed by different companies.
Thank you, Elvin. I see a question now in the chat related to the evaluation criteria. Are evaluation criteria the same for small companies, so SMEs, and large enterprises?
Yes, of course. The criteria are the same, but of course, during the evaluation process, your status will be considered. So the criteria are the same, but we will also take in consideration the fact if the proposal is submitted by a SME, a large company, or a startup.
Okay, thank you, Elvin. There's another question. So, can an entity apply for a facility in the same country? This used to be a limitation in similar EU projects some years ago.
No, there's no restriction in these terms. As I said before, we are no subject to any geographical restriction. Also, this is a free provision of services, and rules that typically are used in other cascade funding and these different type of funding are not applicable in this case. So if you're coming from, you're a startup or a SME in France and you ask for the usage of one of the upscaling or testing facilities in France, there absolutely will be not a problem you to provide the service if you will be awarded as a winning entity, of course.
Thank you, Elvin. So I don't see any more questions now. So it's 25 past 11 almost. So we may leave the floor to Girolamo Mincusi from Alphanov, who's going to do presentations on Alphanov facilities and laser texturing within the NewSkin project. So Girolamo, the floor is yours.
Okay, thank you very much, Romain. Thank you. So thank you everyone to follow this webinar. So I work for Alphanov. My name is Girolamo Mincusi. So we are part of the project NewSkin, and we are amongst the technological center that are providing a value proposition that will be open for external enterprise. So just a few words about Alphanov. We are based in Bordeaux, in southwest of France. We are part of the excellence cluster Route de Laser, and we are, let's say, a technology center for optics and laser. Here you can find some key figures about our activities in the last years. So I would say that ultra short pulse laser and femtosecond laser in particular are the key technology, are one of the key technology to generate a wide variety of surface structures in the nanometric and the micrometric scale. Here you see, starting from the left to the right, some of the structure and that we can generate on the surface. So from nanometric sites on the left, 1 dimension, 2 dimension, to micrometric sites with the so-called D-lips that can generate these spikes that you can see here in the middle. We are able to generate hierarchical structures, so structure at different scale from micrometric to nanometric, and we can manage also another technology that produce structures in the range of 100 of micron, let's say. So what is interesting is that every different morphology can that we develop on the surface can induce a different surface property, so functionalize in a different way the surface. And we cite here some of the key properties that we can generate on the surface. So we can have a surface that turns out to be super hydrophobic, or that can absorb the light, or that can show antibacterial effects, or that can have anti-icing properties, anti-fouling behavior, and so on, let's say. And interestingly, there is no coating, so there is no modification of the material composition of the surface, meaning that we increase the material added values in a way. In a previous project that has been granted, that we were participating, and his name was Trey Clean, we found the way to generate antibacterial surface, and we developed this machine that include a laser femtosecond with the very high power, 350 watts, 10 megahertz, and a system that is a polygon scanner that can scan the beam over the surface, and the machine was able to generate, so to process surfaces as large as more or less 1 meter square. The main outcome of the project was to antibacterial texturing of an injection mold that is that has been used for let's say electro appliance application. But we want to improve, and the target of the project NewSkin for us is really to target the mass production. So to do this, we developed this new machine that you can see here, in which we pass from batch production, so from foils to foils production, to a continuous approach through the concept of roll-to-roll processing. So we have the same laser, the same scanner here, you can see, but the substrate we process can be will move under the laser through a roll-to-roll process. I will show you some more details about the machine. The machine includes a system for inline monitoring. The system for inline monitoring is based on diffractometry. So basically, we measure the light diffracted by the structures, regular structures that are generated by laser on the surface, and we compare the spectrum that we obtained with the theoretical spectrum that has been calculated, making an hypothesis on the structures we are generating. So we compare, let's say, the experimental with theoretical one, and we choose the one that best fit to the experimental results. And this way, we can calculate, for instance, the period and the age of the structure that we have generated on the surface. Here you see some pictures of the machine we developed, and I will ask ALPHA-RLH to please click on the video and to show the video. Yeah, here is one of the video that we have generated. Okay. Yeah, so here you see the process. The part that has been textured is identified by this dispersive effect. So it's a rainbow color you see. On the left you see the laser, and right you see the speed of the process. So it's quite speed, let's say it's quite fast. Here you see the laser that we implemented in the machine, and this is the scan. So here you have this is the scanner we use, and here you see the inline monitoring system. So we can reach throughput as high as 5 minutes per square meter, which are very interesting for industrial application. And here you see some of the samples we did. Here are some of my colleagues that participate with me to make this. Yeah. So if I go on, thank you for the video. Yeah. So we did some optimization of the process. So on the left here, you see how does the surface looks like when you make SCM analysis, and when you vary the scanning speed of the beam from, let's say, 50 meters per second up to 200 meters per second. And we found that 50 meters per second is maybe the best, because we observe a degradation of the regularity, which is specified by the Fourier transform analysis here. And then we fix the scan speed to 50 meters per second, and we try to optimize the throughput by increasing the line speed of the coil of the material, and we pass from 3 millimeters per second up to 10 millimeters per second, and we found that it's still good what we observe at 10 millimeters per second, which correspond to 5.5 minutes per square meters. Here you see some of the samples. We have been texturing a coil that was of stainless steel that was long 15 meters in nearly 1 hour. The inline monitoring that we use has been validated. So here you see the signal relative to the period versus for 3 millimeters per second, and for different linear speed of the roll-to-roll system. And as you can see, the system is quite stable. So filtering has been done to improve the signal, and then implemented in the machine. In the meantime, we can measure as well the age, and the age of the structure is around 200 250 nanometers. So the period that I previously showed is around 1 micron, a little bit less, which is both are consistent with the literature, and it's possible to see if the direction of the structure change through an analysis of the polarization. So I would like to add that given the age of the structure, it's possible to deposit on top of our structures some nano coating to improve the behavior of to, let's say, enable multifunctional surfaces. So what is interesting is that once you have a coil, you can go from the coil to a product by using different technology. So either you are happy just of the coil because your application needs just a coil without any shape, or you can transfer by molding your structures over, for instance, a polymer. Here you see the test with it of transferring, so molding, and you see on the left, this is where the profile of the structure we generated, and on the right side, you have the profile of the structure after the molding, and which looks quite good. Or another possibility, and tests are ongoing with another consortium called Foam Planet, are to make forming, so to give the shape you are looking for through the forming process. The tests want to understand if the forming process makes some degradation on the morphology and on the properties of the surface. So we will have results very quickly. So I show you the machine. I show you the possibility we can of the surface structures we can have. I want to give you how can I say? I want to give you an highlights on the different properties that can be developed and that are the objects of the various propositions. So if you want to develop one, for instance, of these properties, then you can apply for the value proposition and we can develop together. So the first is antibacterial. So we observed that the structure we are able to generate reduce the proliferation of the bacteria on the surface. We evaluated a factor 10 to the power 3, so by a factor 1000, which is very important. So surface which are textured reduce the proliferation of bacteria by a factor 1000. Another interesting properties which could be good for several applications like aeronautic, energy, or transport is related to generation of surface which show anti-icing properties. So we can generate on the surface some specific structure, and the resulting surfaces can show an anti-icing behavior, or we can improve the anti-fouling behavior of the surface. This for storage, food industry, or for fuel storage, or electro appliance, or for boat fabrication. And finally, I will cite as well improving of heat exchange, or we can process battery, electrodes, both, let's say, charge extractor or active parts. So that's all for my side, and feel free to make any question. And here are the acknowledgements of some of the partners that contribute together with the European community to the job we did up to here.
Thank you, Girolamo. So I don't see any question in the chat, but I have a question myself, and during this time you might ask or write a question in the chat. So what type of materials can you texture?
Yes, let's say that for the moment we can process metals, first of all. Let's say coils of metal which are let's say not thick, around 200 micron, more or less. This is because the machine can process only material which are not too thick, let's say, in particular for metal. Otherwise, it will not be able to make the roll-to-roll processing. But we can try with the polymer as well. This could be another option. For instance, the coils that you have seen on the on the video is this one is 200 is stainless steel. Is the width is 35 centimeter, and the thickness is 200 micron. So let's say these kind of material are largely compatible with the actual machine that we have up to now. So really, let's say we can make kind of proof of concept and show the potential of the process. But if you are targeting material which are much thicker, then you have to develop your machine for your industry yourself, let's say.
Okay, thank you, Girolamo, for this answer. So now it's 11:40, so we are going to switch to the next presentation, which will be presented by Pablo Bengoria from Tecnalia. So Pablo, the floor is yours.
Okay, thank you. Can you hear me?
Yes, we can hear you.
Okay, great. So thanks, Romain. Thanks for the invitation. I'm Pablo Benguria. I work for Tecnalia with my colleague Marta Brizuela, who is also involved in the project and actually is between the audience. I'm going to present the upscaling, the services we upscaled here for testing facilities for anti-fouling, anti-corrosion, and tribological coatings. A very brief overview about Tecnalia. We are a private non-profit research organization based in the Basque Country in the north of Spain. We are 1,500 more or less employees. We are the biggest private research center in Spain. So we work in many areas, but one of our strengths are the materials area, both the surface engineering and corrosion, anti-fouling, and materials. So I will divide my presentation in three parts. The first two of them are based on the work we do in the lab for simulate conditions in the real life for devices, for surfaces, for materials. We try to simulate those conditions in lab and select the best performing materials among variety that is given by the customer. The last one will be the testing anti-corrosion and anti-fouling solutions in offshore environment, which is quite singular in Europe, and I will try to explain it. So first one is the Triometer, the facility of the Triometer that we have been improving during this project. We perform two different types of sliding and several contact modes. Basically, they are pin on disc and reciprocated surfaces. We can design the testing for ball versus plane or cylinder versus plane. It depends on the application. We can test in a wide range of conditions with lots of 60 newtons, maximum rotative speed of 500 RPMs. We can also test with different lubricants under nitrogen atmosphere, a wide range of temperatures as well. With this data, we can extract very valuable information for the design of the selection of lubricants, or for the selection of coatings and substrates that will be applied in the industry. In the next slide, I will show you very briefly an example of a selection of substrates that we perform in a private project. We had given surface coating that has to work in an harmonic bright year for the aeronautic industry, and they wanted to select which steel substrate will withstand better the conditions during working. So we select the best conditions, and we achieve an improvement from hundreds operations to more than 17,000 operations. So that's pretty much by applying and by the lubricant and selecting the best substrate. So, okay, next one is the testing coatings at high pressure and temperature. Here we have an autoclave laboratory for work where we can work under very high temperatures and very high pressures. Here we select as well the conditions and the media that is happening in the real life. So here we modify a couple of autoclaves in the project for electrochemical measurements and for the implementation of an agitation system for hydrodynamic control. So we can that way we can perform rotating gauge testing, which is quite demanding for our customer. Here you have some pictures of the holders and of the here are the samples that are rotating. This has to be a video, but it cannot be played right now. It can be seen how the samples are rotating and then are introduced in the autoclave. And then when it's closed, we can test here the conditions that we have defined. Here are some specifications that we can test. We can test up to 350 bars and temperatures up to 400 degrees. Rotating or not rotating samples. Well, we can simulate a wide range of service environments with CO2, sulfuric chlorides, and so on. We then determine the corrosion rates and even under cathodic protection. We can also test the performance of corrosion inhibitors in service. We are accredited in several standards that you can see there. And some of the examples of products that can be tested here are anti-corrosion testing, coating testing of storage tanks for industrial applications, for example, or autoclave test of internal coatings for oil pipes, for example. Okay, next one. Okay, next one is an example, the same as before. We had to select between two materials, P110 and L80, in a distilled water media under a temperature of 70 degrees and a high pressure of 220 bars, and with agitation during almost 500 hours. We performed the testing, and we observed the general corrosion rate and the localized corrosion that was quite higher in the first of the materials. So we concluded that the second material withstand much better the conditions that the customer needed. Okay, last one is the testing anti-corrosion, anti-fouling solutions in real offshore conditions. Here we have the HARS lab. Is the first offshore floating laboratory for the evaluation of materials and components in real offshore environment. This is quite new. We had been testing a HARS lab, a previous version of HARS lab, during 3 years now, as I will explain later. Now this is the second version, which is in the port of Bilbao right now, but will be carried to the BMAP area in the following weeks. This is the place where the first version had been during 3 years, and will be this second one during the next few weeks. Will be moved there. It's an experimental area. Maybe it's an experimental area in front of the Basque Coast in Arminza. It's quite interesting. It was designed for testing and demonstrating prototype devices for energy harvesting. But however, the facilities were ideal for us for placing our HasLab there, because it has surveillance, is quite close to the port, while being absolutely open to the storms and swells coming from the northwest in the Atlantic. So, and we have also a submarine cable that can provide with electric power to the laboratory. So, as I said, we designed it in a two stages design. The first one was moored back in 2018 and was retired during September this year. And will be substituted by this HasLab 2.0 that we call, that will be moored during next week. Here you have the website where some more information is available. Here you can see in a diagram the different testing zones that can be performed here. We can perform testing in the atmospheric zone, in the upper part of the structure, in a splash zone, in the deck, and in the immersion zone below the water line. We can even perform testing in the seabed. It's about 60 meters depth, and we can also test umbilicals, connector risers, mooring components, whatever you can imagine, even sensor or communication devices. Here are some examples of the developments that can be tested and validated in HasLab. Corrosion testing is quite evident. We have measured the corrosion rate for all the zones in the HasLab. It's about CX for the atmospheric zone and IM2 for the immersion. Antifouling solutions are quite evident also. We can test here any kind of antifouling coatings that have been developed by the industry and test how do they work in real offshore environment. Aging testing sometimes is not about corrosion or antifouling, but about aesthetic properties or flexibility or whatever that can be tested here as well. The validation of riser connectors and umbilicals is quite relevant. We have two available holes to test any kind of riser or connectors that can be attached here. Offshore communication systems, not so much over the surface water, but below the surface water, which has still some field of improvement. And even testing equipment in service, both over the deck or indoor as well. Okay, in NewSkin project, we will connect this HasLab via umbilical cable to the submarine cable that is already in the seabed in BMEP area. We have already defined and designed the cable, the requirements that we need, and we will connect this cable to the HasLab by the summer next year. So it will be some months since it will be commissioned in the following weeks till the summer, that will be not connected to the grid. But this is so the improvement that will be made in the project. And what happened to the first version of HasLab? Well, we moored it in the port of Bilbao, as you can see here, and we will install here a Dante. We call it Dante. It's a dynamic antifouling testing rig that can test antifouling solutions on dynamic conditions according to the ASTM 4939 standard. Is quite relevant because it tries to simulate the movement of a vessel with speeds up to 15 knots. We have designed it for hosting about 120 probes that can be tested there. The standard established that it has to be 30 days in movement and then another 30 days static. So and then about 1 year. So it will be fully functional by beginning the next year. It depends on some kind of devices that have to come to Tecnalia. And I guess this is the last one. Yeah, this is the last slide. So I hope you enjoy the presentation. And if you have any questions, just let me know.
Thank you very much, Pablo, for your very interesting presentation. So we have one questions from Diego Alfonso Amaya Rojas. So in case of a coating substitutions, it will be possible to test the current coating and the new one, or there is a reference scale for adhesion to the surfaces?
It is referring to the hash lab or to the triometer or to
Corrosion.
to corrosion to the hash lab. Yeah. We can we can test any kind of proteins. I don't think I understand the question. Sorry. Anyway, if you have my email there and my phone number. So if you need to clarify something, you can write me or call me.
Yeah, we will share the PowerPoint presentation at the very end of the webinar, so you'll be able to download it. And of course, if you want to organize one-to-one meeting, feel free to contact us, and you will be able to also have a specific meeting with Technalia, Alphanov, or also the University of Uppsala later. And now, so we can go to the next presentation, which will be presented by Thomas Kubart from the Uppsala University. So Thomas, you may do your presentation.
Thank you very much, Romain. Thank you everybody for listening. Yes, so my name is Thomas Kubart and I am from the University of Uppsala in Sweden. I will not talk that much about the university, but rather what can we offer in frame of the NewSkin project. And I am calling my presentation New Generation of PVD Coatings High PIMS Upscaling Facility. And I'm going to briefly go through some examples, but first I plan to introduce the technology. Of course, we have very short time, so what is most important is really to introduce what kind of possibilities this technology offers. And I will bring up some examples what type of coatings can be, or what type of properties can be improved. But maybe I should start by saying that while Girolamo was talking about nanostructuring surfaces, so adding value by introducing surface structures, this is about adding a thin film or a coating to the surface of a product in order to increase the performance or added value by combining different materials. And I am assuming that at least part of you are familiar with physical vapor deposition coatings. So then I will try to show the possibilities both to people who already use coatings and look for ways how to improve what they already have. But I will also try to show some examples to those of you who are considering to maybe make this next step. Yeah, okay, how can we improve our product? How can we, or what type of coatings can we use? And as I said, I will mention some examples, but this is a technology that's generally useful. So to begin with, hopefully many in the audience have already heard about Magnetron sputtering, one of the most commonly used physical vapor deposition technique to coat surfaces. And it's really useful and it's widely used and it can be scaled up. So that's one of the main advantages. It's fairly flexible and there are machines that can coat substrates that are 3 times 6 meters. So it's a real industry process. However, as an example, I'm showing a typical titanium nitride thin film. And as you can see, typical thin films or coatings, they are columnar. which is not always bad, but sometimes it's simply that the existing coating is not good enough. And what we do here in Uppsala and what we offer in the NewSkin project is well, modified magnetron sputtering, where a large part of the material that's being deposited, it's no longer neutral atoms, but rather ions. And because we are using ions, we can provide more energy to the film that's growing, and we can make it denser and in general better. And here is an example of, for instance, titanium oxide thin film, where by changing the growth conditions, we can go from a columnar to very dense and featureless microstructure. And this is very useful in many cases. I will not talk about the technology as such. I will just mention that still this process or this technology is compatible with magnetron sputtering. So if you know magnetron sputtering, you can do high power impulse magnetron sputtering too. It's just that the way the plasma or discharge is created is different, but otherwise the hardware is compatible, or it's the same. Rather, what can the NewSkin project offer to you? So I've mentioned surface engineering and coatings, and in this project we can start from a lab scale. So for those of you who don't have a specific material or product, we can help on a lab scale to identify suitable surface coatings and do some testing. And then we can also do such coatings on a large scale. And there are several partners involved in the NewSkin project. So here in Uppsala, we can do coatings in a roll-to-roll configuration on foils. So here's an example of a foil coated with a transparent conducting indium tin oxide. But it's also possible to use this high PIMS technology on metal strips and sheets through Fraunhofer Institute, and they have machines that are for fairly thick substrates or rolls. And there is also Technalia. Pablo actually mentioned some of the testing facilities, but there is also a coating facility, Technalia, for complex pieces and large components. So depending on where you are in the product development, the NewSkin can offer everything from small pre-study or feasibility study on a lab scale to real semi-industrial production scale. That was about the machines and technology. And now I thought I briefly go through few examples just to give you a taste of what can be done. But I have to stress at this point already that what we are talking about is more a technology. So if I am showing a titanium oxide coating, that does not mean that we have to stick to titanium oxide. We can use this technology to make aluminum oxide or other materials too. So this is really rather an example for you to get interested and then ask, well, can we do this? Can we do that? And then it would be very good to have a more focused discussion. Anyway, so I start from an example of a coating developed by Technalia, solid lubricants or self-lubricating coatings that can provide surfaces with very low friction. And just some examples of the components, and I will not go much in detail, but the advantage of solid lubricants is, as you may know, that these surfaces satisfy low friction even in the absence of lubricants. So they can increase the lifetime, reduce friction, and also prevent damage in case there is loss of oil or lubrication. Our technology is useful also for optical materials. And here I'm showing one example of titanium oxide. That's of course an interesting material for optics, where by increasing density of the deposited coating, we can increase the refractive index. So in this case, it was like from 2.4 to 2.6 when the ionized deposition process was utilized. And again, the way this works is simply when we are getting more dense structure, then we are getting closer to the bulk properties of the material in question. There are of course different requirements on the coating material. So if the density and smooth surface is desired, then we have ways to tune the deposition process. In some cases, there might be some other requirements, and then maybe we modify the deposition process in a different way. There is one more example, and this one is from microelectronics. So we also tested our technology for metallization, and in this case, it was very thin conductive films of cobalt on silicon oxide, and we could see that we could improve a lot the resistivity of our very thin films. So at a thickness of about 20 nanometers, we could reduce the resistivity by about an order of magnitude. There is a bit of illustration showing the microstructure, so we can increase the grain size and this way improve the conductivity. But I should point out in this case that right now we are, for instance, exploring this approach for conductive corrosion resistant contacts. So in fuel cells, for example, there are requirements for very good electrical conductivity and corrosion resistance. And then of course, this is the way to go, to make a dense and conductive material that will also resist corrosion. And I'm slowly running out of time, so I will conclude by my last example, again, a different topic. So at some point, it's interesting to combine surface structuring and surface coatings. And this is an example of a nanostructured surface, a moth-eye nanostructure that's imprinted in a polymer material. And of course, such nanostructures are wonderful. They have really great properties, but they are mechanically not very strong. So here we've shown that if we coat such a surface with a thin layer of titanium oxide, we can improve both the thermal stability and also mechanical properties of the surface. And because titanium oxide is also photocatalytic, we could even make the surface super hydrophilic after UV illumination. So that was very briefly an introduction of the PVD deposition facilities or high-PIMS facilities from the NewSkin project. And just to summarize, so high PIMS or high power impulse magnetron sputtering, it's a very useful alternative for those who are already dealing with coatings. But I also need to point out that it's not like a completely different technology. So it's what we always do is we evaluate the performance of the coated system against standard sputtering, because there are cases when just adding a coating to a surface will improve the properties and the performance will be good enough. So then there is always a question of, yeah, what exact performance or properties are desired. But anyway, through NewSkin, we offer a set of upscaling facilities to really test different ideas on a larger scale. But we also have the know-how to help with the product and process development. Thank you very much, and I would be happy to answer questions if there are any.
Thanks a lot, Thomas. I don't see any now in the chat, but I have one, and it's more like questions to confirm something you mentioned. You explained that you can combine surface texturations with the use of high beams. Does it mean that, for instance, we could use Alphanov technologies for a client and combine it with the high beams to have the double effects or many effects expected on the surfaces?
Absolutely. That's something we have to do in the project. But of course, it's like always. It would be very good to have a good test case because it's difficult to say this surface is better than that surface unless we really test a specific property. So hopefully we will also get more requests to what type of performance is desired.
Okay, thank you, Thomas. So I don't see any more questions. So we may conclude for this webinar. So at the end of this webinar, you understand that we can offer several types of technologies, and you can also combine this technology for a specific project. So for instance, you can use the laser texturations offer from Alphanov and other laser other RTO who are developing laser technologies within NewSkin. You can use a high beams technology from the Uppsala, Fraunhofer, and Technalia. And also, if you are a company developing surface texturations technologies such as coatings, laser, or high physical vapor depositions technologies, you can use the testing facilities from the project. So Technalia has presented his harsh lab, for instance, but we have other testing technologies that you can find on the NewSkin platform. So the NewSkin platform is an online tool that aims at gathering 3,000 users who are interested in developing some surface technologies and using these surface technologies. So it's interesting for RTO, for end users such as SMEs, large enterprise, for researchers to join the platform in order to monitor technological development in this project. Also, you on the NewSkin platform, you will have the opportunity to network with the NewSkin partners and also to increase the visibility of your own company, because you can once you have created your user profile, you can create your organization profile, and this is a means for you to advertise your projects, your products, and your services. And of course, as Elvin Fetai has said during his presentation, it is mandatory for open calls participants to register on the platform before. So you may click here on the top of this slide to check the platform, and we invite you to register to join our NewSkin community. So I see another question in the chat. We have some time to answer it maybe. So the application price could cover other things besides the laboratory test, construction of prototype, coating development. Yeah, the application, well, through your applications, we can also cover commercial development. So the clusters such as ALPHA-RLH, RLH, Confindustria, and other partners can also help you to advertise the development that have been done within the open calls. Therefore, it will also help you to commercialize the product and to increase the TRL of your product and bring it closer to the market. So that's quite important offer as well within the NewSkin open calls. So if you do not have any more questions, I think we can close this webinar. And of course, this webinar will be available on the NewSkin YouTube channel, so you will be able to see it again. And if you would like to organize a one-to-one meeting with one of the technical partner or with one of the cluster, just feel free to send us an email, and we can organize a meeting with you in order to prepare your open call applications. Thanks a lot for your attendance, and we hope to stay in touch with you. Goodbye.